Okay, copy down this example. Copy, 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 copy. Okay, so this is an example which is relatively easy if you have a firm grasp on linear dependence and also on what is meant by a linear transformation. Okay, but if you don't have a firm grasp on those two concepts, it's basically impossible in this question. Okay, so I have a set which is dependent. Okay, so this set is contained inside of Rn is dependent and T is linear. Now I want to show that this is dependent. How do you show that something is dependent? Well, you produce a non-trivial dependence relation. So that's my goal. So how can I start? Well, I can start by saying this is dependent. This is dep. So we have a non-trivial d-dep relation. We'll say A1V1 plus A2V2 plus A3V3 is equal to 0. Okay, so non-trivial, meaning that A1, A2, A3 are not all zeros. At least one of them is non-zero. So what's my goal? What am I shooting for? I want to prove that this set is dependent. So I want to find a dependence relation for these guys. So why don't I take this equation, which I have, and apply t to both sides. So therefore, t of the left-hand side, A1V1, A3V3 is equal to t of the zero vector so on the left-hand side, I know that t is linear, right? So I can do two things, which I'll do in one step. Okay, I can distribute across this sum, and the coefficients can move out. We saw earlier that t of the zero vector is always a zero vector. I established that earlier. So maybe I'll add some more detail here. Since t is linear and we saw earlier that t of 0 is always, t of 0 vector is always 0 vector. Okay, we're actually done, right? Because what I have here is, from above, I know that A1, A2, and A3 are not all 0. So this is exactly, this is exactly the non-trivial dependence relation I want. So therefore, we have a non-trivial dependence relation for this set, T of V1, T of V2, T of V3. Therefore, this set is dependent. There is my demonstration. And when I say this, I mean this. I'm referring to this. Okay, copy that down. Pause if need be. Now we'll close out the section with some more vocabulary. Okay, so if you have a transformation from R, say 6 to R3, this is called the domain. This is called the co-domain. T of x, an individual vector, is called the image of x. And then star. And then we'll say the range of T is equal to the set of all images image of x. Should underline that. So the range of T is you just take all those images and you put them in a bag. Okay, this is the same as we did in Sec5 and Cal1 for the range of a function. Okay, it's not the same thing as codomain. Sometimes they coincide, but sometimes they don't. So in mathematical language, we say the range is a set. So put a brace. Every element is one of these images such that x is in R, well in this case R6.